So let's start how we can insert a node in the linked list. Suppose a linked list is given to you, which is starting with the first pointer, and the nodes are 1, 2, 3, and so on. So if a new node that we want to insert, suppose the item value is 45 and the pointer to this new node is new. So consider case A where we want to insert a node in the beginning. So now my new linked list will start with 45, then 1, then 2, then 3. So when we insert the new node in the beginning, start of the linked list will change. Definitely, here is the start of the linked list, then it will be changed to here. So let's see. When we will call the insert function, we will pass the first in the actual argument. So in the function definition, this first pointer will be copied in the list pointer. So your first is pointing here, your list is also pointing here. So currently this is the beginning of the linked list. What we want to do, we want to make the beginning of the linked list here. So list should point here and the new arrow next should point to here where the list is pointing earlier. So we graphically you can see we want to do this. So my beginning is here 45 and 45 next will be 1, 1 next is 2 and so on. So 45 will be added as a first node. So we want to write this two statement, new arrow next equal to list. New arrow next is equal to list and list is equal to new. List is equal to new. So list points where the new is pointing. We cannot write the list is equal to new statement before this. What happens if you write this? If you write list is equal to new, then this link is broken. List is now having the value is equal to new. So new arrow next is equal to list. This we cannot write later on. So always you need to be careful that this statement you need to write first, then you need to write this statement. Otherwise you will lose this link. Okay. Let us go to the case B where your key is not 1, means you do not want to insert a node in the beginning but somewhere in between the linked list. So our key indicates if my key value is 2, then I want to insert a node before 2. So we need to find n1, a pointer. N1 provides a link to the node before the key node. So if I want to insert a node before this 2, then I want n1 here, one node before the key node. So I want a n1 pointer here. So for that, what we will do, we will write a statement like this: n1 arrow next arrow item is equal to key. N1 arrow next arrow item is equal to key. If it finds, then n1 is pointing here. Otherwise we will move n1 forward. N1 is equal to n1 arrow next. So first we will point n1 to the beginning of the list, and then we want this condition to be satisfied. Once this condition for key value 2, n1 arrow next is equal to n1 arrow next arrow item is equal to key. This satisfies here. N1 arrow next arrow item is equal to key is satisfied. So we do not need to increase the n1. Otherwise we need to write n1 is equal to n1 arrow next. N1 comes here and then we again check n1 arrow next arrow item is equal to key. So it will proceed. Once you get n1, now my n1 is pointing here. Graphically we want to do this, that n1 arrow next should point to new and new arrow next should point to n1 arrow next, because n1 arrow next is this. So new arrow next should point to n1 arrow next. So we need to write this two statement. New arrow next is equal to n1 arrow next. New arrow next is equal to n1 arrow next. And n1 arrow next, n1 arrow next is equal to new. Here also you need to be careful. You are not supposed to write n1 arrow next is equal to new before this. If you write this statement first, n1 arrow next, n1 arrow next is equal to new. If you write first, then this link is broken, and then we will not get the address of 2. So this statement comes first and this will come later. You need to be careful. So this is the case B, where we want to insert a node anywhere in between the linked list. Let us see the execution of insert function. The insert function definition. This is the creation of linked list. Print the linked list, and then this is the creation of the linked list. Print the linked list, and then we will call the insert function by passing first as the argument. Here you can see the formal argument is list. We are creating a key node pointer n1, another pointer which will save the address of list. This is the new node creation, scan the value, and as well as scan the value of key. Here, what is key? Key is the item value before which we want to insert a node. So if a linked list is having 1, 2, 3, 4 and you want to insert a node before 2, then your key value will be 2. First we are checking if the list arrow item is equal to key, then the meaning of this is list is pointing at the beginning, start of the list, and list arrow item means the first value is equal to key. That means we are going to add the node in the beginning. So the new arrow next is equal to list, and list is equal to new, as we have seen in case A. So this becomes our case A. We are inserting the node in the beginning. If it is not the case, then we will go in the else part. In the else, we need to find n1, where n1 is nothing but n1 will give the pointer just before the key node. Okay, so n1 arrow next arrow item is equal to key, then our n1 is found and we break. Otherwise, n1 arrow next n1 arrow next equal to null. That means we have not we have not found the value which is given in the key, and we reach at the end of the linked list. So we traverse throughout the linked list, but we did not get the value key available in the linked list. Suppose your linked list is having the item values 1, 2, 3, 4, and suppose user enters the key value 55. So definitely we are not going to get a node with the value 55. So we reach from the start, we go up to the end of the list, but we did not get the key. Then this condition will be true, and at that time your n1 will become null and we break. So if you found this condition, you got your n1, then we print this message and we break. If you do not get, then we make it null and we break. If you do not, any of this is correct, then you increase the n1. n1 is equal to n1 arrow next. So from the first node you go to the second node and your loop will continue. From second you go to the third and it will continue. From third you will go to the fourth and it will continue. So when you break this loop, after that you will check that if n1 is not equal to null, means you have some value of n1, then we write this statement: n1 arrow next is equal to n new arrow next is equal to n1 arrow next, and n1 arrow next equal to new. We will write this two statement. In else part, we will print the key node not found, and finally we will return the list. So now let's see the output. We are creating the linked list. The linked list is 1, 2, 3 and minus 999. So this is your list. Item value for the node is 45 and the key value is 1. So we want to insert a node before 1. It's a beginning. So 45, 1, 2, 3. That is my new linked list. Again the same I am creating, running the program again, minus 999, and now the 45 is a new node and key node is 2. So I want to insert 1, 45, 2, 3. Okay. So I hope you got this. How to, okay, we are printing the list first, then we are calling the insert function, and then we are printing the list again so that you can see the updated list. Thank you.